Okay, good morning everybody. Today we are going to learn about simple harmonic motion. Okay, so the simple harmonic motion, the concept of the simple harmonic motion, in this case, we use a pendulum. Okay, so we suspended a pendulum. For example, this pendulum is on the equilibrium position. Okay, and then the pendulum will be swing to the other position. Okay, so that the position will take place in this part. Okay, so if I put the sign in point A in here and going to the point B, so then the ball or the pendulum will go back to another direction, okay, such this, to the point C. Okay, so it's going back here, so that it will swing. Okay, so the simple harmonic motion is the motion of the pendulum from its equilibrium position. Okay, so the equilibrium position is this. Okay, so if we just take a line from the equilibrium position, line like this, and then line from this equilibrium position like this, and we can get the distance between them. That is y. So y is the deviation of the pendulum. The deviation of the pendulum is the equations of the deviations of the pendulum is a sine theta, where the sine is the angle between the pendulum from point A to point C, or the angle between point A and point B. Okay, so then it can be developed, become a sine omega t. Okay, so now A is amplitude. Amplitude in the unit, international unit, is in meter or amp. So omega here is the angular speed. The angular speed is measured in radian per second. And then t is time, and y itself is deviation. So, if we look here, that what will the requirement to get the maximum amplitude is that the sine theta must be 1. What does it mean? The amplitude, the maximum amplitude, is equal to the y if the sine theta is equal to 1. Yes, that means that the theta must be 90 degree. Okay, so the theta here, the angle must be 90 degree to create the maximum amplitude. Okay, so then, and the next is the velocity or the speed of the pendulum. Okay, so the speed of pendulum, or v. If you are talking about speed and velocity, okay, so just we don't get the point of view of the difference between speed and velocity. Okay, so the v here is the differential of deviation to time. Okay, so means that t a sine omega t over time. Okay, that means that so we difference the sine omega t to time, it will be omega times a times the differential of sine omega t is cos omega t. So the v is this. So what is the requirement to get the maximum speed the maximum speed or v max is equal to omega times a if cos omega t is equal to 1. What does it mean? What does it mean 1? It means that omega t must be 90, must be 0 degree, because cosinus 0 is 1. So this angle must be 1 to get the maximum speed. So the speed in this point is maximum, but the speed in this point is minimum. So the maximum going to it is decreasing in speed and then stop in here and then going back to the maximum speed. Then we are going to learn about acceleration. The accelerations of the pendulum, or A, is equal to A is the first differential of V over time. Okay, so that it means that the differential of omega A cos omega t to time. That means that the acceleration is, because omega t is omega times A, the differential of cos omega t is sine omega t times minus in here. Okay? So that the acceleration is omega squared times A minus omega squared times A sine omega t. And we can see that this part is y, is the deviation itself. So minus omega squared times y. This is the equation of the accelerations of the pendulum. Okay? So if you are going to say that the omega itself is equal to 2 pi f, or also 2 pi over t. So for example, it is known that the equations of the wave is y is equal to 2 sine 2 pi t in centimeters. So you are asked what is, first, what is amplitude? Second, what is velocity? What is acceleration? What is maximum velocity? What is maximum acceleration? And also, what is frequency? What is period? Okay, so we answer this. Our equations is y is equal to 2 sine 2 pi t in centimeters. So we can compare from the first equation that y is equal to a sine omega t. Okay, so we can see that here 2 is equal to a. So a is equal to 2 centimeters, because a is in centimeters, this length. And then the next is v. V is the first difference of deviation. Okay, so it equal that v is equal to a times omega times cos omega t. Okay, so can see that here that the omega is 2 pi. So a is 2 times 2 pi, which is omega, which is a, and cos omega, which is equal to 2 pi t. Okay, so it is 2 times 2 pi is 4 pi cos 2 phi t. This is the equations of the velocity or the speed of the wave. Okay, so if you are going to ask that the maximum speed, the maximum speed or maximum velocity is equal to omega times a. Omega times a, which is equal to 2 pi times 2, which is equal to 4 pi centimeter per second. Okay, and the next is the acceleration. The acceleration is minus omega square, times y. It means that minus omega is 2 pi square times y. Y is a sine omega t, or 2 sine 2 pi t. Okay, so it means that a is equal to minus 4 v square times 2 sine 2 phi t, which is equal to minus 4 times 2 is equal to minus 8 p square sine 2 pi t. Okay, and we continue here. So the A max is equal to our equations, which is minus omega square times a, which is equal to minus 2 pi square times 2, which is equal to minus 4 square times 2, minus 8 pi square. So we are going to ask, the next is frequency. Okay, so the omega is 2 pi f. Omega in our questions is 2 pi is equal to 2 pi f. Okay, we ignore this, so our frequency is equal to 1 hertz. And the period is 1 over f is 1 per 1 is equal to 1 second. Okay, I think maybe this will help us to explain about the simple harmonic motion. Thank you for your attention.